We will be discussing about the angular wave function. As we know that the total wave function psi is represented as the product of the radial wave function Rr and the angular wave function which is given by A theta phi. About radial wave function we had discussed this earlier also, and today we'll discuss about the angular wave function. So the total wave function is Rr into A theta phi. Now what is A theta phi? It can be positive or negative, and it is difficult to have a pictorial representation of the angular wave function. Why? Because it depends on the angle. As angular wave function, it depends only on the direction. Direction of electron with reference to the nucleus. And radial wave function, it depended on the distance of the electron from the nucleus. So angular wave function is direction dependent, and A square means the square of the angular wave function. It gives the probability of finding an electron at a given direction theta and phi at any distance from the nucleus. Distance from nucleus from 0 to infinity. Now for 1s orbital, we can show the angular wave function as, suppose it is x-axis, it is y. Mm. This is x, this is y, and this is z axis. And here It's just like a circle for the 1s orbital. So we here we are representing it as a circle, but actually it is in three dimension. So it is just like a sphere. So this diagram, which is represented in the form of the boundary surface diagram. These boundary surface diagrams are made to visualize the solid shape of the orbital. This diagram is drawn to visualize the solid shape of the orbital having about 90% of electron density. Means having the maximum amount of electron density that we can show by the boundary surface diagram. And inside this, there is about 90% of the electron density. So it is the orbital representation in the form of boundary surface diagram or contour diagrams. It is also written somewhere contour diagram. And this is the boundary surface diagram, and which is used to visualize the solid shape of the orbital having the 90% of electron density, because the three dimension it cannot be drawn on a two-dimensional paper. So in two dimension we are representing it as a boundary surface diagram or the contour diagram. Now inside a particular orbital, the sign of the wave function, it may get changed, and this can be represented by the presence of a node. So here in case of the s orbitals, 1s, 2s or 3s, there is no node present. But in case of p orbital, we have the nodes. So we can show for the px, py and pz orbitals. X, y and z axis. And this is the 2px orbital. Similarly, 2py along the y axis and 2pz, which is along the z axis. Here the function is changing the sign from plus to minus, and this point is called a node. This is a node. This is a node, and here it is a node. Here the probability density is zero, means the probability of finding the electron is zero at this point, and this point. So these are called the nodes. Now we will draw the d orbitals. It is in the xy plane, so this is 3d xy. It is plus, minus, plus and minus 3d xz. X-axis, z-axis, and it is in the it is better to show it like this. You can show this is the these are 3d orbitals 3d xy yz and zx. YZ, sorry, this is YZ. Along in the Y and Z plane. This is in YZ plane, this is in XZ plane, and this is in XY plane. So it is better to remove this Y axis from here, and I can say this is XY in the same way. This is the XY plane. So it is XY plane, it is XZ plane, and it is YZ plane. So 3d orbitals are like this, and two more d orbitals are there, dx2 y2 and dz2. Dx2 y2 is in the xy plane. Along the axis there are four loops. plus and minus minus 3D x2 y2 and 3D z2. Plus minus minus. Now these diagrams are representing only the angular part of the wave function. This is only the angular part of the wave function, and the total wave function is represented as the product of the radial wave function and the angular wave function. Now, what we will do, we will draw the diagram for the f orbitals. So f orbitals are shape of the f orbitals is like tetrahedral, and these f orbitals are 7 in number. So we can show f orbitals like this: x, y, and z. We'll use different colors. This is fx, x2, 3y2. Then x, y, z. This is fy, 3x2, y2. Then fxyz. Fyz square. fxz square. So x, y, fxz square and fz x2 y2. fz x2 y2. Like this, fx2 fz x2 y2, and then we have drawn the six f orbitals. Now seventh one, x, y, z. This is f z cube. So these are the 7f orbitals, and these are the complete angular wave functions for the sp, d, and f orbitals shown here in the form of contour diagrams or the boundary diagrams. Thank you.